Regression can be applied in two ways. First, we follow general steps. Define variables, choose the regression type, check assumptions, and fit the model. In prediction analysis, the goal is to forecast future values. For example, predicting procurement cost or delivery delays from historical trends. In explanatory analysis, we aim to discover which variable matter most, such as whether transport cost or material prices drive total spend. Both approaches give procurement teams the insight they need for data-driven decision. Machine learning models learn from past data to predict or automate decision. You might choose a simple decision tree, an SVM, or advanced model like random forest or neural networks. A key step is splitting your data into training, validation, and test sets. The training set builds the model, the validation set runs hyperparameters like learning rate or tree deep, and the test set checks how well it performs on unseen data. In procurement, ML can identify supplier risks, detect fraud, or automate classification tasks. With tools like PyCaret, even non-programmers can take advantage of this technique. In supervised learning, we work with labeled data. Past example with known outcomes to make accurate predictions, like forecasting delivery delays. Unsupervised learning has no labels and finds hidden grouping or unusual patterns such as clustering suppliers by reliability. Semi-supervised learning combines both approaches. We start with a small set of label data and use it to label a much larger dataset. This is especially useful in procurement when we might have detailed records for only a fraction of suppliers but still want to build accurate board models. Clustering is an unsupervised learning method that groups similar items together without predefined labels. In procurement, we might cluster suppliers based on metrics like performance, price, and risk. The most common method is k-means, which creates groups based on similarity, while hierarchical clustering shows how suppliers relate to each other. For example, if three suppliers have high volume and low risk, we can manage them under the same contract strategy. This helps tailor procurement actions to the unique characteristic of each group. Classification assigns data points to categories using supervised learning. In procurement, this might mean labeling suppliers as low, medium, or high risk, marking orders as compliant or non, or flagging frauded invoices. The process starts with labeled data, which the model used to learn patterns. Algorithms like decision trees, logistic regression, or SVMs then predict the correct category for new data. By automatic classification, procurement teams can make faster, more consistent, and more data-driven decisions. The confusion matrix compares prediction to actual outcomes, showing not just accuracy but also where the model makes errors. By understanding these patterns, procurement teams can better manage supplier performance and reduce delivery risks. A neural network is made up for layers and interconnected neurons, each transforming its inputs and passing the results to the next layer. During training, these neurons adjust connection weights to reduce prediction errors. This allows the network to capture a very complex pattern in procurement data. But it also means it works like a black box. We can't easily see how weights are distributed or which variables matter most. In procurement, neural networks can predict suppliers' failures, detect fraud, and forecast prices. And with tools like Orange, they can be built without writing code. A classification tree is a supervised learning method that splits data into categories based on decision rules. Each branch represents a condition and each leaf represents an outcome. The model is trained on labeled data, tested for accuracy, and proved if needed to avoid overfitting. In procurement, classification tree can be used to classify purchase orders by urgency, identify preferred suppliers based on price and performance, or support make or buy decision. For example, if the minimal percentage step price reduction is greater than 0.10, the estimated price is less than equal to 4,423. The prolongation period is more than 5 days, and the subcategory is furniture, then the savings percentage can be calculated as 0.422. XGBoost, short for extreme gradient boosting, is the powerful machine learning algorithm ideal for complex procurement data. It works by building a series of decision trees that learn from previous errors to improve prediction. In procurement, we can use XGBoost to forecast supplier risk, predict tender success, or even estimate final price. The process begins with defining and clear prediction goals, preparing and cleaning the data, training the model, tuning it for maximum accuracy, and then evaluating its performance. For example, a procurement team might use XGBoost to predict late deliverables based on supplier history, past contracts, and performance metrics, enabling proactive supplier management and cost savings. Large language models, or LLMs, are AI tools that can read, understand, and generate human-like text. In procurement, they are especially used for handling large amounts of documentation, such as summarizing RFP's response, drafting supplier contracts, or extracting compliance clauses. The process is simple. You define the task, give the model a clear prompt, and then review its output for accuracy. By integrating LLMs into procurement workflows, team can save time, reduce manual effort, and focus on higher value strategic decisions. AutoML, or automated machine learning, is a way to build high-quality predictive models without having to manually select and fine-tune each algorithm. In procurement, this means you can start with cleaning historical data, define the outcome you want to predict, and let the AutoML platform automatically try different algorithms, optimize patterns, and pick the best one. For example, a company might use AutoML to predict which trends will attract bids under budget. The system can test dozens of models in minutes, pick the winner, and integrate it directly into dashboard, speeding up insights and reducing the need for manual coding. Python in Excel brings advanced analytics into the hands of everyday Excel users. Instead of switching to the separate data science tool, you can run Python code right in your spreadsheet using the Py function. This means you can apply machine learning models, perform complex statistical analysis, and clean large datasets, all from within Excel. Currently, Python X in Excel runs entirely in the cloud, so you don't need to install anything locally, but this may change in the future. For procurement teams, it opens the door to sophisticated forecasting, supplier risk modeling, and automated data cleaning even for those used to only basic Excel analytics. Low-code and no-code tools make analytics accessible to users without programming skills. PyCaret is a Python-based low-code library that can run classification, regression, clustering, and anomaly detect in just a few lines of code. Orange data mining takes it a step further with a visual drag-and-drop interface for building models and visualization. In Procurement, these tools can predict supplier risk, segment categories, and automate compliance checks. They are perfect for quick projects, training seasons, or teams looking to adapt machine learning without a steep technical learning curve. In summary, procurement data analytics use statistics, forecasting, and machine learning to improve decision. You don't need to master every tool. Start with simple ones like dashboards and regression and build from there. Thank you for your attention.